Hello student, myself Melissa, and today we solve our last example of Macaulay's method, and that is for cantilever beam. Okay, now first of all solve this example. We read the data properly. Here a cantilever beam of 3 meters span long is loaded as shown in figure. Find slope and deflection at free end using Macaulay's method. This is the last example for cantilever beam. Now here E is given in 200 gigapascal and I is equal to 160 into 10 raised to 6 mm raised to 4. Now this given beam is cantilever and UDL is given 10 kilonewton per meter for 2 meter span, and second 20 kilonewton is given at free end. Now first step of this Macaulay's method is find out support reaction. So that here support reaction for cantilever beam, A is our fixed and C is our free. So we find the support reaction as A point. First of all mention support reaction RA. RA is equal to our load UDL is equal to 10 into 2 and our point load 20. So that first support reaction at A point is equal to 40 kilonewton in up direction, because in this cantilever beam load is given in downward direction, the support is balanced in up direction. Second, find out moment at A. Here no inclined load, so that axial force HA is equal to 0 and moment at A is equal to this UDL 10 into 2 and 2 by 2 and this 20 into 3 at with respect to A. Load into distance by 2 plus point load 20 into distance 3. But this is 2 to cancel. First is 20, second is equal to 60. Our moment at A is equal to 80 kilonewton into meter in anti-clockwise direction, because this is the inducing moment in clockwise, support A resist in anti-clockwise direction. Okay, here we get RA and moment at A. But now look at this beam. UDL at start at A point and stop at B point. That means we find out slope and deflection. Here we convert this given beam in equivalency. So that first of all draw this beam support at A and given UDL at B point, but to convert into equivalency we spread all UDL load on entire span, and B to C we apply extra load so that balance it. This is our section XX, okay, point XX, and we find out support reaction just now, that is our 40, and moment at A anti-clockwise mention here. This is moment at A 80 kilonewton into meter, and this UDL is given 10 kilonewton per meter, and this UDL is also 10 kilonewton per meter. At free end point load is given 20 kilonewton, and to make an equation of moment consider this is as X. Okay, now look at this. This is UDL, this is UDL, and this is section at moment point load is given. Now next to make a equation of moment M with respect to this equivalent beam M. This section and all over loading on left hand side clockwise is plus and anti-clockwise is minus. Okay, first support reaction rotate clockwise 40 into X. Right here first 40 into X. Now this moment is given at A point. Okay guys, here no distance are there, so that only and only consider moment, and this moment is anti-clockwise, so minus 80. In example number 2, if you remember, the moment is given on span, so that I multiply this moment with x minus a raised to 0. But in this case, moment is given at A point, and this is the starting point of fixed beam, and the distance is 0. So that we have to not multiply x minus a raised to 0. Only and only moment, minus 80. Next, UDL is given, and this UDL rotate with respect to S in anti-clockwise direction 10, then x and x by 2. UDL load into distance and distance by 2. Then again this extra UDL rotate clockwise direction, plus take plus, then 10 and distance left, this is 2 meter distance and this is 1 meter distance. So you write x minus 2, x minus 2 by 2. Now what is the equation of differential? ei d square y dx square is equal to minus m. Change the sign. First convert positive to negative. Second minus 80 will be positive. And here 10 by 5, 5 x square, and this term again minus 5 x minus 2 cube. Now first, according to rule of Macaulay's, integrate this term. Integrate, okay, ei, what is the integration of d square by dx square? That is dy by dx. dy by dx is equal to first term minus 40, integration of x is equal to x square by 2, and add constant c1 in first term, plus second 80 into x, second 5 x square, integration of x square, x cube by 3, minus 5 x minus 2 raised to cube by 3. This is the equation of slope, and this is our first equation. Now again, right here, again integrate first equation. What will be? ei y, okay, integration of dy by dx is equal to y, then minus 20 x square, x cube by 3, plus c1x plus c2, and 80 x square by 2. Then there is no need to divide. 5 by 3 take remain 5 by 3, x raised to 4 by 4, then minus 5 by 3, x minus 2 raised to 4 by 4, and this is the equation of deflection, okay, deflection, and this is our second number equation. Now next, in next step, apply the boundary condition. Okay guys, write down, apply boundary condition. Okay, look at this. Boundary condition always apply at support A. That means at support, here support are given at A point and C is free end. If you want to take a boundary condition at A and C, then the rule will be changed. But here we solve the all example from left to right. Okay, we consider left as origin point and right as a section. So we follow the same rule, left to right. If we solve with this Macaulay's method for a cantilever beam, and this A is fixed and C is free, so that apply the boundary condition at support A. Okay, now the deflected shape of this beam is like this one. This one is A point, and at A point both value are 0. At A point rigid, that is theta, and dy by dx is 0, and also y, and deflection is equal to 0. Because fixed support is rigid, it will be not allowing for any type of slope and deflection. After fixity some distance, slope and deflection will be start. Okay, so that if we consider A point as a boundary condition, at A point slope and deflection both are 0. Now first boundary condition right here, first point x is equal to 0. Now at first point, which value is 0? That is dy by dx is equal to 0. Now this is the equation number 1. Okay guys, if we put x is equal to 0 and dy by dx is equal to 0, in that condition our first constant c1 is equal to 0. Now in second, at that point A, x is equal to 0 and again y is equal to 0, because at fixed support slope and deflection both are 0. Now this is the equation number 2. Now again x0 divided by this 0, then y0. In second condition, our constant C2 is equal to 0. Now, first find out here what constant C1 and C2 are 0. Now, find out slope at free end. Okay, at free end, that means C point, and at C point, what will be the distance x from left hand side? That is 2 plus 1, 3 meter. Right here, x plus 3 meter. Okay, now what is the equation of slope? Okay, mention EI. Right here, our first equation of slope, EI dy by dx is equal to minus 20 x square plus C1 plus 80x plus 5 by 3 x cube minus 5 by 3 x minus 2 raised to cube. Now put the value, this is EY, and in replace of dy by dx we can write also theta c, because at C point we find out slope. We can write here theta c also, minus 20. What is the value of x? That is 3 square, constant C1 0 plus 80, and value of this x is equal to 3 meter plus 5 by 3 x is equal to 3 square, then minus 5 by 3, and x is equal to 3 minus 2 cube. Here we count all term because all term not equal to 0. Here after simplifying this theta we get 103.33. Now what is the value of E? E is equal to 200 gigapascal. And if you want to convert this gigapascal in Newton mm square, 1 gigapascal is equal to 10 raised to 3 Newton per mm square. That is the unit conversion of gigapascal. And I is equal to 160 10 raised to 6 mm raised to 4. Put the value of this E, I in this equation. Theta C is equal to 103.33 divided by EI, and this are in Newton mm. In first previous example of overhanging beam, if the value are given in Newton mm, then we convert EI into Newton mm, so that here our numerator is given in kilonewton into meter square, so that convert this kilonewton into meter square in Newton mm. And 1033, what is the conversion of this kilonewton meter square into Newton mm square? That is 10 raised to 9, and E is equal to 200 10 raised to 3 into 160 into 10 raised to 6 is equal to, answer is equal to 3.22 10 raised to minus 3, and unit of this slope is radian, and answer is positive, so in clockwise direction. Now second, find deflection. Okay, and again this deflection, that is we find deflection at free end. Okay, at free end x is equal to 3 meter. Right here x is equal to 3 meter. Next, what is the equation of slope EIYC? And after simplifying the equation of x is equal to 3, after simplifying we get answer 213.33. Okay, now what is YC? YC is equal to 213.33 divided by EI, and answer of this numerator in kilonewton meter cube. Now what is YC? YC is equal to 213.33 into 10 raised to 12, because conversion of 1 kilonewton into meter cube is 10 raised to 12 Newton mm cube. Okay, and divide by E. E is equal to 200 into 10 raised to 3 and I is equal to 160 into 10 raised to 6. Okay, and answer y is equal to 6.669 and unit is mm, plus answer so indicate in downward direction, that is the deflection at free end. Here we take all type of beam in Macaulay's method, and our Macaulay's method is complete. In next session we start our new method, and that is moment area method. Okay, and in detail I will explain you at the time of method. Okay, just we stop the session.